Very good morning. So, today's topic being discussed for the subject fundamentals of data science is correlation analysis. So, let us look at the concept of correlation analysis. We have two variables x and y, and are they correlated or not? Okay. So, if they are correlated, then say x has a predictive power on the value of y. There is one term called as correlation coefficient in statistics. What this term does, it measures the degree to which y is a function of x and vice versa. If the correlation coefficient value is negative, then it indicates negative correlation. If it is positive, then it indicates positive correlation. If it is 0, then it indicates no correlation. So it will be varying between -1 to 1. When it is negatively correlated, it is called as anti-correlated. Meaning, suppose x goes up, then the value of y goes down. So to make things more simpler, let us look at this. One of the types of correlation coefficient is Pearson's correlation coefficient. If you look at this, the Pearson's correlation coefficient is given by the term R. And if you look at these three graphs, you are saying the leftmost graph is having a correlation of 0.4, which is a positive correlation. And on the rightmost side, the correlation coefficient R is minus 0.4, which is a negative correlation. Okay? While the middle one is having a zero correlation or no correlation. Here we are referring Pearson's correlation coefficient, one of the correlation coefficients. Now, what is the purpose of correlation coefficients? Okay, they're terms in statistics. They're used to measure how strong a relationship is there between two variables. Okay, here in this graph, at least you can see that. Let us say there are two variables. This is positive correlation, this is zero correlation, this is negative correlation. Okay. One type of correlation which is very prevalent and famous is Pearson's correlation. It is given by R. Okay. And it is mostly used in linear regression to identify the relationship and how strong the relationship is. So as mentioned previously, the correlation coefficient value varies between -1 to +1. If the value is 1, then it indicates a positive relationship. -1 indicates a negative relationship. 0 indicates a no relationship at all. Now, let us say positive correlation is there. It means, let us say there are two variables. So, x and y are having a correlation coefficient of 1 means positive correlation. Positive correlation means if x increases, then y also increases. For example, the shoe sizes go up with the foot length. Suppose there is a negative correlation, okay? So the opposite will be true. For example, here, the amount of petrol or diesel decreases in correlation with the speed. 0 means there is no correlation. Pearson's R formula, this is a correlation coefficient formula indicated using this. N into summation of x into y minus summation of x into summation of y divided by square root of n into summation of x square minus summation of x square again summation of y square minus summation. This formula. This formula is a Pearson's correlation formula. Okay. Now to make things simpler, I'll just show you my Excel sheet calculation here. This is the Pearson's correlation coefficient formula. Pearson's correlation coefficient is indicated by R. Okay. So What I have to do in the numerator, I have to calculate a summation of x into y minus summation of x into summation of y. N, denominator has n into summation of x square minus summation of x square, again n into summation of y square minus summation of y square. Okay. Now, to understand it further better, we'll just look at this formulae. As mentioned, the two most frequently used correlation coefficients are Pearson and Spearman. Today's topic under discussion is Pearson's correlation coefficient. See, this is the formula here. R is the term used to indicate Pearson's correlation coefficient. The formula is summation of I is equal to 1 to n xi minus x bar yi minus y bar, which is a numerator, divided by the denominator is square root of summation of I is equal to 1 to n xi minus x bar whole square, again square root of summation of I is equal to 1 to n yi minus y bar square. Okay. So here xi and yi are the data points. X bar and y bar are the means. X bar and y bar are the means. X bar and y bar are the means. So if you look at this formula and if you look at this formula, so we are finding subtle difference there. Okay. Why that subtle difference is there? We'll just try to identify. But before that, we'll try to how do I split this equation and try to identify that what happens with that. For example, the numerator part is indicating the covariance and the denominator part indicates the standard deviation. The numerator part indicates the covariance and the denominator indicates the standard deviation. Okay. So let us say the data points of x and y are strongly correlated. Okay. So then always this values of xi should be greater than this mean. Same thing is valid for y. Okay. If you look at the numerator value will be positive when both the values are above 1 into 1 or below minus 1 into minus 1. Okay. The numerator will be negative if one of the value is positive, one of the value is negative. Okay. Which indicates the negative correlation. This numerator aspect determining the sign of correlation is very useful and it is indicated by covariance of x and y. So what you are doing is you are calculating, when you are calculating the numerator, actually you are calculating the covariance of x and y, which is given by the formula xi minus x bar yi minus y bar summation I is equal to 1 to n, I is equal to 1 to n. While the denominator indicates the variance of the variables, okay, depending on their standard deviations, So now let us take one example. Actually what I did was I just Googled for this Pearson's correlation coefficient calculation. This is actually from this website eagri.org, which is a Tamil Nadu Agricultural University initiated e-learning program. So I am just citing them because I am using them. So let us look at that. What it is saying, this is the Pearson's correlation coefficient. This is the Pearson's correlation coefficient. This is the formula for that. Xi minus x bar, yi minus y bar is the denominator and is the numerator. Denominator is x minus x bar whole square, square root of 1 upon n minus 1. Again, y minus y bar whole square, square root 1 upon n minus 1. This is simplified as like this. If you simplify the upper one, you get this new one, which is summation of xy minus summation of x into summation of y divided by n. Again, the denominator part will be summation of x square minus summation of x bar square divided by n. Again, square root of summation of y square minus summation of y square by n. Okay. And the test significance is indicated by this formula. Mod of r divided by square root of 1 minus r square upon n minus 2. Anyhow, let us try to again check how to do this. This is the formula which we have agreed about. Summation of x into y minus summation of x into summation of y divided by square root of summation of x square minus summation of x square is equal to, again summation of y square minus summation of y square. This formula you compare with this formula. They are one and the same, and this also is one and the same, which again is similar to this formula. X minus x bar y minus y bar. Here y bar and x bar are the means. Y bar and x bar are the means. So let us see how I did the calculation for this. Forget about all these other details. Just look at them as numbers. Look at them as numbers. What I did, I have one x value, x variable. I have one y variable. Okay. So x and y I have plotted. These are the x and y values for the different entities. After x and y, what I did, I calculated xy. So this will be taking care of the summation of xy. Then I calculated x square. This will be taking care of this x square. Then I calculated y square. This will be taking care of this y square. So once I did that, I can take the summation of xy. It will give this value. I can take the summation of x. It will take care of this value. I can take the summation of y. This will take care of this value. I can take summation of x square and summation of y square. It will take care of this value. Okay. So this is how you will be doing the calculations. Let us look at this example also, which is there in E-Agri. So this is the formula for Pearson's correlation coefficient. He has given an example here. What is there? He wants to find the correlation between advertisement cost and sales. This is the advertisement cost in thousands. This is the sales in lakhs. Is it not? It means what? Suppose I am spending 39,000. The sales is up to 47 lakhs. Suppose I am spending 82,000 for advertisement. The sales is up to 62 lakhs, like that. So we need to find the correlation coefficient. So correlation coefficient means what we need to find out? We need to find out whether it is positive correlation, whether it is no correlation, or whether it is negative correlation. Okay. So these are the three aspects we need to find out. So forget about all these details. Just let us see how many samples are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the value of n will be 10. Now, what I have to calculate? Let us remember again what I have to calculate. I have to calculate summation of x. Is it not? So x, summation of x. I have to calculate summation of y. Y, summation of y. I have to calculate summation of xy. I have to calculate summation of xy. I have to calculate summation of x square. I have to calculate summation of y square. So this is how I have to calculate. Now same thing I have to do here. First I have to take summation of x. So summation of x, let us say if I take x as this advertisement cost and y as this sales in lakhs. So summation of x is coming to be 650. Let us say this 39 plus 65 plus 62 plus 90. Hopefully this will be 650. And summation of y will be 660, which is 47 plus 53 plus like this. So summation of xy will be how much? I have to x into y. I have to do the multiplication. Then I have to take the summation of xy. Summation of x square will be how much? So I have to take x square plus all these x square I have to add. Then I have to take the summation of x square. So like this, summation of x, summation of y, summation of xy, summation of x square, summation of y square, I have to calculate. After that, I have to use the Pearson's correlation coefficient formula. Where is the Pearson's correlation coefficient formula? This is it. So take summation of xy minus summation of x into summation of y divided by n, and in n value is 10. So divided by square root of summation of x square minus summation of x square by n, square root of again summation of y square minus summation of y square by n. So I will be taking summation of xy, which is 4 5 is 604, summation of x, which is 650, summation of y, where is summation of y, which is 660, then divided by n. The value of n is 10, so that is 10. The denominator part will be summation of x square. So summation of x square is 47648 minus summation of x square. Summation of x square will be 650 square divided by 10. Similarly, summation of y square is 45784. 45784, 660 square by 10. So this is coming to be 0.7804. So what it is indicating? The Pearson's correlation coefficient is coming to be 0.7804. 0.7804. It means what? The correlation coefficient is positive. How much it is positive? It is 78% positive. It means it is on the higher side. So it is positively correlated. Means what? There is a positive correlation between the advertisement cost and the sales. The advertisement cost and the sales. Rest of the terms we can easily identify and discuss later also. Test statistics we have to calculate, and then the inference we have to do, and ultimately what it is saying is there is a positive correlation between advertisement cost and the sales incurred incurred. So try to relate this and try to execute or implement one or two positive or negative and zero correlation examples. I'll try to show you one R code also. Let me check where it is. Give me a minute. Yeah. If you look at here, remember this is the formula. So if you find some variation in the formula, you know that some simplification is done. Now look at this. I have written the R code. I have taken X values as 1, 2, 3, 4, 5, 6 like an array. Y values as 1, 3, 6, 2, 7, 4, 5 like an array. Now I am in R for correlation coefficient. The formula is, or the tag is COR. The variables are X and Y, and which correlation coefficient method I am using? Pearson's. If you look at this, when I print this, it is coming to be 0.5357145. The same thing you can implement in your Python code also using the libraries. Okay. So hopefully you understood this correlation coefficient, that is Pearson's correlation coefficient.